Salt levels and sodium in soils have been a hot topic for the last couple of years. So can you just touch on some of the information that you know about salt levels, with regards to certain crops such as corn, alfalfa, and soybean, and how are they measured, and how do we account for these, in different types of fertilizers?
Certainly. The first thing I would mention is let's separate sodium and soluble salts, even though sodium is part of soluble salts. But sodium is not a desirable nutrient, and so we want to take a look at that separately. So on your report, you're going to have a reading in parts per million. But I think more importantly is the base saturation sodium. It's a percentage, and that more than anything is what we want to focus on rather than that parts per million, because it will be different as far as a parts per million value based on the CEC, the cation exchange capacity. In other words, a parts per million value sodium of 50 parts per million will certainly be a problem on a loamy sand and possibly a sandy loam, but a soil with a higher clay content, 50 parts per million is not an issue. So that's why I would encourage you to focus more on base saturation. And when we look at that, I generally want people to look at 1% as kind of a level to key in on, or at least a critical level. If we get to 2%, it can certainly affect production on some crops. Plants in general have different tolerances for sodium and salts in general. But if we get up above 1, it's something to look at and possibly think about amending. We can amend sodium with things like gypsum, elemental sulfur, depending on the type of soil we are dealing with. Like lime, it takes water to amend sodium with gypsum or elemental sulfur. So, and time as well, but it can be done. And the amount to apply would certainly depend on the amount of sodium that's in that soil. Now, when we think about where that sodium came from, in general, we're going to see higher sodium values where manure has been applied year after year on the same field, whether it's livestock, swine, or poultry litter. We can begin to elevate those sodium levels. Also, irrigation water. As you go west and you see more irrigation, there can be sodium in that water and over time accumulate. Depending on the rainfall, average rainfall, that could elevate in the soil over time. Also, on a yearly basis, it's something to look at. Did you get well above average rainfall? Well, you will see that in the soil report. Possibly in those years, that sodium drops. Or if you have a drier year, as far as rainfall, you can see that sodium elevated in those situations. Another scenario where you could see sodium is river bottoms, where flooding had occurred at some point in time or multiple times in the past. I've seen elevated sodium levels in those situations. Now, soluble salts includes a number of different elements. So not only sodium, but chloride, calcium, magnesium, potassium, sulfate, carbonate, and bicarbonate. So when we run a soluble salts on our report, which is the same thing as electrical conductivity, we're measuring how well that soil can conduct an electrical current. And we're that value, which is given in millisiemens per centimeter, is a value that shows us or shows you the presence of salt in that soil. And again, sodium is not desirable, but some of these other elements that I just mentioned obviously are major and secondary nutrients. And we don't normally think about something like potassium being a problem, but in certain situations it can when it's elevated. And so as far as what to look for on that soluble salt value, again, similar to sodium, if we get to that 1 to 1.5 millisiemens per centimeter, that's kind of a critical level. And we certainly want to think about, first of all, what is driving that value? Is it sodium? If it's not sodium, what is it? It could be calcium. Why is that? It could be potassium. It may be driven by irrigation water that has a lot of bicarbonate in it, which in turn creating various other problems. But understanding what is driving that soluble salt value is key, and understanding and figuring out how to manage that is how you will be successful. And I see a lot of these situations again as you move west, where crop production is very, very important, but yet these situations force them to manage that a different way than, say, the Midwest. Part of the question had to do with salts in fertilizers, and I just want to make the point that that's really a different scenario than when we talk about salts in the soil. As far as fertilizers go, every fertilizer has a salt index, and it's compared to sodium nitrate, which has an index of 100. And so there are fertilizers that have an index around 80. There are some fertilizers that have an index around 20. But when we think about salt indexes, it's not nearly as important in the soil as just thinking about how many salts in particular you are putting in, let's say, a starter in a band of some kind. A lot of folks will use starters when they plant. It may be in furrow, it may be 2x2, 2x2x2, and understanding the total amount of salts that you have in that band is what we're talking about in that situation. It's not the salt index that is associated to a particular fertilizer. So wanted to be clear on that. If there are any specific questions, would be glad to discuss that if anybody is interested.